August 1956. The air in Dahlgren, Virginia, is thick with the humid promise of a late summer storm. But inside the Naval Surface Warfare Center, the atmosphere is a different kind of charged. It's the height of the Cold War, a silent, global chess match played with slide rules and secrets. A young African-American woman, Gladys West, steps through the doors of this institution, a fortress of military science and rigid social codes. She is one of only 4 black employees on the entire base, and one of only 2 women in her division of mathematicians and programmers. The stares she receives are a mixture of curiosity, dismissal, and outright hostility. The path that led her here was paved with defiance. Born to a family of sharecroppers in rural Sutherland, Virginia, Gladys knew from a young age that her mind was her only ticket off the tobacco fields. While her peers saw their futures tied to the land, she saw hers in the abstract beauty of numbers. She graduated at the top of her high school class, securing a full scholarship to Virginia State College, a historically black university. There, she majored in mathematics, a discipline dominated by men, and graduated with honors, her intellect a beacon of undeniable brilliance. But in 1956 America, brilliance was not enough. Her degree, her ambition, her formidable mind, all of it was filtered through the distorted lens of race and gender. She walked into an office where her genius was expected to be both utilized and contained. Segregated brilliance. Her desk was not among her white male colleagues. It was in a separate area, a physical manifestation of the Jim Crow laws that governed every aspect of Southern life, even in a federal facility dedicated to national security. The water fountains were segregated. The cafeterias were segregated. The very lines of respect and authority were drawn in black and white. Yet, the numbers she was given to analyze knew no color. They were the cold, hard data streaming in from a world on the brink of a new technological age. Her initial assignment was a task of immense strategic importance: calculating and verifying the trajectories of submarine-launched ballistic missiles, the Polaris missiles that formed a cornerstone of America's nuclear deterrent. Imagine the scene, the constant rhythmic clatter of mechanical calculators, the low hum of the base's first major computer, the Naval Ordnance Research Computer, or NORC. This behemoth, one of the most powerful computers on Earth at the time, filled an entire room. It processed data on vacuum tape and magnetic tape, and Gladys West was one of the few minds trusted to program it, to feed it the complex differential equations that would predict the precise flight path of a missile traveling thousands of miles. Her work had to be perfect. A single miscalculation could mean the difference between a successful deterrent and a catastrophic failure. While her colleagues might discuss their work over lunch in the main cafeteria, she would eat alone, poring over her printouts, her focus absolute. She was a ghost in the machine of the Cold War, her contributions essential, yet her presence rendered almost invisible by the systemic prejudice of the era. She wasn't just solving equations, she was navigating a labyrinth of social and professional obstacles designed to keep her in her place. Every correct calculation, every flawlessly executed program was a quiet act of rebellion. It was a testament to a mind that refused to be limited by the boundaries others had built around her. While the world outside saw a nation divided, Gladys West was already looking beyond the horizon, beyond the atmosphere itself, her mind charting courses across a globe that had not yet learned to see her. The data from those missiles was just the beginning. It was training her for a far grander, more complex task: to map the very planet her work was meant to defend. But how could someone so pivotal to global understanding, someone whose calculations held the key to future navigation, remain so utterly unknown for more than half of a century? From that constrained environment of segregated offices and classified missile data, Gladys West's work escalated dramatically, moving from the trajectories of weapons to the fundamental nature of the planet itself. The question of her invisibility deepens when you understand the sheer magnitude of her next project. By the 1960s and into the 1970s, the space race was in full swing, and satellites were beginning to orbit the Earth, not just for spying or communication, but for science. West was assigned to a groundbreaking project analyzing data from the GeoSat satellite, which launched in 1985, but was built upon decades of preliminary work she was central to. Her mission, a task of almost unimaginable complexity for the era, was to create the most accurate mathematical model of the Earth's true shape. This model is known in geodesy as the geoid. Now, we are taught in school that the Earth is a sphere, or maybe an oblate spheroid, slightly flattened at the poles. But the reality is far more complicated. The planet's mass is not uniformly distributed. There are massive mountain ranges, deep ocean trenches, and variations in the density of the Earth's crust and mantle. All of these factors create subtle fluctuations in the planet's gravitational field. The result is that the Earth's shape, if defined by mean sea level, is an irregular, lumpy surface, the geoid. Think of it less like a perfect marble and more like a slightly misshapen potato. For most of human history, this didn't matter. But for a satellite, it is everything. A satellite's orbit is a delicate dance with gravity. If your model of Earth's gravity is imprecise, your prediction of the satellite's location will be wrong. And if you don't know exactly where the satellite is, any data it sends back is fundamentally unreliable. This was the problem Gladys West was tasked with solving. Geoid calculation using data from satellite altimeters, which measure the precise distance between the satellite and the ocean surface, she began to build her model. She programmed early IBM supercomputers like the 7030 Stretch, feeding them enormous data sets and complex algorithms written in Fortran. She worked to refine the mathematical model, accounting for the gravitational pull of the sun and moon, tidal forces, and other variables that could throw the calculations off by even a few meters. This was not a simple one-time calculation. It was a grueling, iterative process. The computers of the day, while powerful, were prone to errors and had severe memory limitations. They would churn for hours or days, spitting out reams of paper covered in numbers. It was West's job to meticulously check this output, to identify anomalies, debug the code, and refine the parameters. And when the machines reached their limits, or when a particularly complex part of the model refused to resolve, she took over. She would take the printouts back to her desk and perform the painstaking calculations by hand, using her intellect and sheer force of will to solve problems the most advanced computers of the day could not. This could take weeks. It was a monumental undertaking, a fusion of high-level mathematics, computer science, and an almost artisanal level of scientific rigor. Her work was foundational. Detailed and dense technical reports circulated within the Naval Surface Warfare Center. These reports contained the bedrock computations, the precise mathematical expressions that described the geoid with an unprecedented level of accuracy. This model would become the essential reference frame for all future satellite geodesy. It was, in essence, the mathematical key that would unlock the potential of global satellite navigation. But as we look back through the archives, a critical question emerges. Who signed off on these reports? Whose name appeared on the title pages and at the top of the memos? And why did the foundational work of a brilliant black woman, the very architect of this new understanding of our planet, remain largely uncredited and buried in classified files, even as it was about to propel a technological revolution that would change the world forever? The answer to why Gladys West's name remained in the shadows is woven into the very fabric of the system she worked within, but the impact of her work could not be contained. Those painstaking computations, the geoid model she refined through endless hours of programming and manual calculation, were not just academic exercises. They were the essential, non-negotiable blueprint for what would become the Global Positioning System, or GPS. The principle of GPS is triangulation. A receiver on the ground, like your smartphone, listens for signals from multiple satellites orbiting the Earth. By precisely measuring the time it takes for those signals to arrive, the receiver can calculate its distance from each satellite. With signals from at least 4 satellites, it can pinpoint its exact location in 3-dimensional space: latitude, longitude, and altitude. But this entire system hinges on one critical assumption: that we know with absolute certainty where the satellites are and where the surface of the Earth is. And that is precisely what Gladys West's work provided. Without her precise geoid model, her mathematical description of Earth's exact shape and gravitational field, the system would be riddled with errors. A GPS might be able to tell you your location within a few hundred meters, making it useless for navigating a city street, landing an airplane, or guiding a rescue team. West's model corrected for the gravitational anomalies, allowing for the astonishing accuracy we now take for an everyday miracle. For decades, the world navigated by her intellect. Every time a driver followed a digital map, every time a pilot set a course, every time a hiker checked their position, they were relying on the integrity of a system built upon her hidden labor. GPS legacy. The technology she enabled became ubiquitous, woven into the infrastructure of modern life. From coordinating global shipping and financial networks that rely on GPS for precise timestamping, to enabling precision agriculture that feeds the planet, to allowing first responders to locate people in distress. Yet, her name remained completely absent from the public narrative. She retired from Dahlgren in 1998 after 42 years of dedicated service, her contributions known only to a small circle of colleagues. The story of her rediscovery is as remarkable as her career. It wasn't a historian or a journalist who uncovered her legacy. It was her sorority, Alpha Kappa Alpha. For an alumni event, West submitted a short biography outlining her work. Her sorority sisters read it and were stunned. They understood immediately that one of their own was a true hidden figure, and they began a campaign to bring her story to light. This community-led effort finally broke through the institutional silence. In 2018, at the age of 87, Gladys West was formally inducted into the Air Force Space and Missile Pioneers Hall of Fame. The commendation explicitly praised her work on the geodetic model that proved to be the foundation for the global positioning system. The recognition was just, but it was also decades late. Her story is not a simple feel-good tale of eventual triumph. It is a profound indictment of a system that consumes the brilliance of marginalized people without offering credit or acknowledgement. It forces us to confront a vital and deeply unsettling question. How many other foundational discoveries that shape our modern world remain attributed to the wrong names or to no name at all because of systemic barriers that denied brilliant minds their rightful place on the map of history? Gladys West helped chart the globe, and in remembering her, we are not just giving credit where it is due. We are redrawing our own maps of scientific history, making them more accurate, more complete, and infinitely more just.